India. Hello. How's everybody doing? All right. Let's talk about Laravel, Kubernetes, and you. Before we do that, let me tell you a little bit about who I am. My name is Justin, as you heard, infrastructure engineer at Laravel. Prior to this, I was at WP Engine and Remax, but over the last year or so, I've been busy building out the cloud. And then, yeah, like you heard also, when I'm not building out the cloud or working on Kubernetes, this is some of the activities that we're doing. Recently rebuilt a four-wheeler. And then when we're not rebuilding the four-wheeler, taking the boat out, going out on the kayak. But let's talk about Kubernetes and cloud. Before we do that, let's talk about what is Kubernetes. Kubernetes is, you can think of, very similar to like Forge. It gives you a way to deploy your application, but it does so in a declarative way, which means you describe what the application should look like, how many replicas it should have, things like that. And then Kubernetes will manage running all of that for you. So let's jump into what that looks like. But before I do that, let's talk about the goals of this talk. I want to teach you how to deploy a brand new Laravel application on Kubernetes. I want to talk about what are some of the difficult parts of managing Kubernetes and Laravel deployments. And then I want to show you how cloud handles some of those challenges and give you kind of a behind the scenes look. So let's jump into our demo. So what I have here is I have just the basic Laravel application. Haven't done anything to it. I'm going to go ahead and open up in PHP Storm. And so we want to deploy this application. One of the first things that we're going to need is we're going to need a Docker file. And for the sake of this demo, we're just going to use a very simple Docker application. We'll use PHP 8.4 demo if the demo goes through. And then the first thing that we need to do is we need to copy our application to a folder. So we'll do copy.to/app. And then we'll set a work directory to that app as well. So basically, anytime we go to this image, we'll always go to our app directory and we'll work from there. And then for a web server, what we'll do here in this case is we're just going to use PHP artisan serve. And then we'll use, we'll specify the host to be 0.0.0, which just means listen to any and all interfaces. And then we're going to be super explicit for the sake of the demo. We'll even say use port 8000, just to make sure I keep it consistent. And then another thing that I like to do for my infrastructure is I like to do a makefile, just kind of as my entry point into the infrastructure. So in this case, we're going to worry about building the Docker image. So we'll add this build endpoint where we can say make build. And on that build endpoint, we're just going to do a simple docker build-t, which is going to say build an image with this tag, and we'll pass in a tag here. In this case, I'm going to use a variable. So I'll add a variable to the top. Oops. Just like this. We'll call it Laracon. And then we'll put a period to say build everything in this directory. So now, with any luck, we can say make build, and we should build an image. Great. And then now we want to deploy this image. So how I like to structure this is I'll do a new file in a new folder. Kates /deployment. .yaml. And now we'll start to declare how we want this deployment to look. So one of the first things we're going to do in Kubernetes is we're going to specify the kind. In this case, we're going to do a deployment with an API version. And in this case, we're going to say apps v1 for Kubernetes just so Kubernetes understands what type of object that we're giving it. And then we'll go through the rest of the spec here. The next important thing that we need to give it is we need to give it a name. The name is completely arbitrary, but it's important to have a name that describes the deployment that we're working on. In this case, we'll just call it Laracon. For the next part, we need the spec. And on the spec, we're going to start to define how we want this deployment to work and how we want it to control the underlying parts of the deployment, which we'll get into. So the first thing that we'll do is we need a selector. And the selector is going to control it's going to tell Kubernetes how to control the pods that are deployed. And the pods are the container images that we built before. So in this case, again, it's arbitrary. It can be anything we want. We'll use a match label. And then we'll use the name that we want. We'll call it Laracon Web, because we'll handle web traffic with this. And then the next part we need to define is the template. And the template is the meat of the deployment that helps describe, tells Kubernetes, this is what I want running all the time. So in this case, what we want is another spec that points to containers. And again, we can give it a name that we want here, and then we specify an image. The image has to match the image name that we gave it before, so we'll use Laracon. And then we'll specify an image pull policy. In the pull policy, we have a couple choices here. We could say always pull, and this basically means always go out to the internet and pull in the latest image. We could say never pull the latest image, or we could say if not present. In this case, because there's lots of choices out there as far as deciding how to deploy to a Kubernetes cluster. In this case, what I'm going to use is a program called Rancher Desktop. Docker Desktop has Kubernetes built in. You can find it there as well. Or if you have the ability to run Docker images, there's a great Docker image called Kind, which stands for Kubernetes in Docker. And you can use that to deploy to as well. But again, in this case, I'm going to use Rancher because it works pretty well. You install it, you get all these tools that you need in order to make these deployments. In this case, I'm going to use, you'll see this alias that I have here, K, which is really kubectl. So from here, I can say kubectl apply, and we'll pass in the file that we used before. An important part. When you define the spec, so this error here is also telling me that I had an invalid value. It doesn't match the labels. When you define the spec, you also have to make sure you specify what metadata to use. And it doesn't go under spec, it goes under template. So the template also has metadata that when it builds the pods, it'll add these labels that we want. And then we want the labels to match the selector that we gave it up here before. So we're going to say Laracon Web. And now if we try this again, we can see the deployment happened. And if we say kubectl get deployments. Oh, hang on, give me 1 second to clean up the previous runs here. Okay. And if we rerun this again, now we can see it deployed. If we get our deployments, we can see we have one replica. It just started. And in this case, what we can do is we can easily scale this one replica. We can say kubectl scale deployment, and then give it our deployment name. We can say replicas equals 3. And now if we get that same deployment again, we can see now we have 3 replicas running. And if we get the pods that make up that deployment, we can see there are 2 pods running at 10 seconds and 1 pod, the original pod, before we scale it up at the 36 seconds. And if we get the logs for these pods, so kubectl logs, we can see that it's telling us the service is running. And if we try to go there, we can't get to it, not yet. So what we're going to do now is we'll go ahead and we'll start to access these deployments. And one of the very first things we need for that is we need a service. So again, we're going to specify a version here. We'll call it v1. And then we need the kind. In this case, we'll say service. And then we'll start on the spec. For the spec, we need the port. So you can think of a service as a DNS entry that goes into your Kubernetes cluster and points to your deployments or your pods and tells your Kubernetes cluster how to access this deployment. So in this case, we're going to use our port 8000, and we're going to target the port 8000. So we'll listen on 8000, and we'll target 8000. And the other thing that we need here is we'll need another selector. So we need to tell what pods, again, to go try to connect to. So in this case, we're going to use our same selector before. We'll say app Laracon web. And then one thing that we'll do here as well is we'll give this a name so we can reuse this later. So that makes up our service. Now let's define our ingress. And you can think of our ingress as a basic Nginx service. So we'll start with an API version here. In this case, it'll be networking v1. The kind will be ingress. And then again, we'll start on metadata. Oh, and metadata needs to also go in the service. Let's do that. We'll call that as Laracon service. And then let's see. So we need Laracon ingress. And we'll do our spec. So the very first thing we'll do for spec here is we'll do rules. And we'll do a host. So in this case, because I'm doing it on my local host, I'll use laracon.localhost. For the next part, on this ingress, we're going to accept HTTP traffic, and we want to route it to a backend. And our backend, in this case, we're going to use our service that we made before, Laracon service. And we need to specify a port. And instead of using an actual port, we're going to use the name that we made before, web. And then we need a prefix type. Or we need a path type, and this time, for the path type, we're going to say prefix. And then for the actual path, we'll say slash. And so what we're saying here is any traffic that comes to laracon.localhost at the path slash, at the root, anything that matches on that prefix, we're going to send back to our Laracon service. So now, if we apply our deployment again, oh, 1 second. Try that again. Cool. Once we apply that, we can see that our original deployment was unchanged. The service was unchanged. In this case, it should be created, but the ingress was also created. So now, if we go to Laracon.localhost, we can see our application up and running. Thanks. So one thing that we'll do, just to kind of see a full deployment with Kubernetes kind of end to end, is we'll make a change to this. So we'll go to our routes, web, and in this case we'll return host equals get host name. And then if I go ahead and save that and I go back to it, actually, let's save that and we'll say make build. We'll build our image again. When this is all finished, if we go back and we hit refresh, nothing changes, right? That's because we haven't redeployed the application. It's still running the old code. So what we're going to do in this case is we're going to say k rollout restart deployment, give it our deployment name, and we'll hit enter, and that will automatically go ahead and redeploy that application and change it for each of those pods. And now if I keep hitting refresh, you can see each one of these pods are handling those requests, and it's being load balanced across all of them. Okay. So that looks awesome, right? That's an easy way to manage your deployments. And it sounds great, but like, what do I need to watch out for? So like we talked about in the very beginning on that building stage, this was very easy on a local host and a local Kubernetes cluster, but when it comes time to deploy it and set up your Kubernetes cluster somewhere else, you're gonna have to worry about making those Docker images. You have to worry about setting up your container registry. You have to worry about the life cycle on your container registry and cleaning those images up, because if you guys are pushing images to those registries every day, those are some of the things you have to think about, as well as the permissions to push the image in the first place. And ideally, one of the things you also want to do there as well is add security scanning on those pushes. So typically your registry, you can enable this and it'll scan for vulnerabilities. And so that way you know what's running on your Kubernetes cluster and if you have any security concerns to address. But all of that are GitHub workflows that you also have to set up as well. So it could be a lot of work. And if you do something like cloud, it handles all these steps for you. The deploy stage. So like when we did kubectl deploy, some things to think about. You have to set up the permissions to pull those images down. You have to set up the Kubernetes cluster in the first place. You know, manage Kubernetes. You have to manage the underlying nodes. So those nodes will just be EC2s or VMs running somewhere. They will need security updates of their own. You have to worry about ingress, setting up TLS or something to manage that. And then with success, when your Kubernetes clusters start to take off, you have to worry about isolation and then enabling teams and branches and alternatives. Yeah, so just a lot there. And then there's things like hibernation. If you want to get into adding hibernation, it can be a lot of work to also set this up. And then whether you're deploying to your own Kubernetes cluster or you're deploying to cloud, a thing to keep in mind is that those Docker images are ephemeral. So each time that container restarts, it goes back to your original image. There's not a long-lived image on there, so there's benefits to that, in that if the disk fills, the container is going to restart, and that helps not get paged in the middle of the night. And then that also helps with scalability, because one of the requirements with an ephemeral disk is that you want to take those anything you upload to those images, say if you're processing images like actual JPEGs or PDFs, you want to put those on an object store as quickly as possible, so that way if the next request comes in, you don't get a 404 for those images, and it works on any of those replicas. So it kind of just teaches you a best practice there as well. Some things to keep in mind for when you start your first migration to your Kubernetes cluster, or you deploy your first time. You want multiple replicas. You know, at least 2 or 3 replicas to kind of handle your traffic or handle anything that might come up. And then you want to oversize those resources to start. Because it's easier once you deploy that application and you go back and you look at your metrics, you can start to size it down. That's a lot less stressful than the alternative, which is you don't have enough resources to start in the first place. And then, yeah, like we talked about again, ingress. It becomes a real chore to kind of manage more host names, more environments. Inevitably, it becomes popular and people start asking you to deploy new environments for them as well, different team members. And then cost. So managing these costs are hard. This is another way that something we tried our best to sweat the details in with cloud, so that way you can really track where those costs are. But this can be hard when you're running your own Kubernetes cluster. But one thing that can help you track that as well is setting up metrics is something that you have to do, right? You have to monitor your connection limits, monitor your response times, build out what SLOs or SLAs that you want to use throughout your Kubernetes deployment, what tells you and your customers, whether that's teammates or whoever that might be, is your deployment, is your infrastructure in a good place? because inevitably you'll be on call for those same deployments, and you want to be able to track on those things so that way you can see where those spikes are before they happen, and you're ready to solve those issues, resolve those issues before they happen, and you're reacting to them before somebody else is paging you and telling you to react to them. And inevitably, again, with more success, you have to take all of that and then repeat that for more regions and more areas, more clusters. So yeah, it's a lot of work, and yeah. But ultimately, let's talk about what else is something like, how can you push this further? And hopefully you guys learned a little bit about Kubernetes, and I can inspire you to go try some of these things on your own deployments. You can look into scaling at a certain time, right? So if you want to scale your workload down during off work hours, or scale it up so you at least have a minimum number of Kafkas during the workday. If you want to scale on a queue depth, say you want at least one worker for every 100 jobs that you have in your job queue, is something that you can do in Kubernetes. You can also scale on a database attribute. So if you know you want at least one worker per user, or whatever your setup might call for, is something you can do as well. And one thing we didn't touch on, all of these were very simple deployments. But another thing, you can get way more in depth with your health checks. And yeah, that wraps it up for Kubernetes. A little bit early, so I'll give you guys some time back, but keep shipping, guys.
This has been also one of the most interesting session for all, because I was checking 1, 2, 3, 4, 5. Can you guess how many people asked you questions? Maybe how many people might have asked you questions? 5, 10, 15, 20?
Yeah.
More than 65 people asked questions. So I would request Kailash Bedarkar, if you are nearby, please come here to save the time. So he has asked an interesting question. How Kubernetes cluster manages to perform efficient with workloads?
How does it manage efficient with workloads?
Yeah.
So a big thing there is managing the nodes as well. You provision your nodes and you watch your nodes. You want to make sure you have a large enough overhead for those nodes. But I mean, it's very similar to running VMs, but you're you're building the platform for people to run those workloads on. And the most efficient way to best do that is to use your resources that you have from like a cloud provider, use your cluster autoscaler, be able to scale those up and scale down as you need them. So yeah,
perfect. And one of the question which seems like a question for many people, they would like to understand the roadmap according to you for beginners who would like to be part of cloud infrastructure experts. So they don't know how to start. They need some advice how to begin, like a roadmap.
A big thing I would say, I mean, start with your deployments, just like we talked about there. Like, just build your simple images, build out the queue workers, do all those kinds of things. And then me personally, I like to automate those things, and you will learn so much from trying to automate that. So, whether you hook up, there's like lots of great Laravel clients out there that will talk to Kubernetes, so you can try those out. But I would say that's a great way to learn, is like, just dive right in.
Yeah, all right. Thank you.